Hello everyone, today we are going to be looking at problems from the American Mathematics Competition grade 12A. So this one's from 2018. I'm picking the geometry questions first because I think that geometry are interesting and they could be good for a warm-up. So this is problem 17. It says that farmer Pythagoras has a field in the shape of a right triangle. The right triangle's legs have length 3 and 4 units. In the corner where those sides meet at a right triangle, he leaves a small unplanted square S so that from the air it looks like a right triangle symbol. The rest of the field is planted. The shortest distance from S to the hypotenuse is 2 units. What fraction of the field is planted? So upon looking at this problem, I encourage you also to try it out, pause the video, and see if you can get the solution of it. Right now is the explanation. So since we have this is the shortest distance from this field S to the hypotenuse, if it's the shortest distance, then this angle must be at 90 degrees. This would be just grade 5, grade 4 geometry knowledge, so that you should know it. You should be able to find out why as well. So if we know that this is 90 degrees and we have an S right here, we're just first trying to figure out the S, and basically we're using all the parameters that's given. A 3, a 4, that's a special triangle where you have 3, 4, and 5, because Pythagoras theorem, 3 squared plus 4 squared equals 5 squared. And then now you have this 2 right here. How do we use the 2 to the max efficiency? What I did is that I drew a line that facilitated me with the problem solving. So I drew a line here as well as here, so that these two lines split the entire triangle into 1, 2, 3, 4 pieces, or 1, 2, 3 pieces. This is a better split. So 1, 2, 3 pieces. The first one, I'm going to set the length here as x. Since this is a square, this should also be x. So the whole area should be 3 times 4 divided by 2 equals 6 units. 6 units, we have x times 3 minus x divided by 2, which is this triangle here, plus this triangle here is x times 4 minus x divided by 2. 4 from here to here, 4 minus x is right here, and then x is right here. Plus, now it's turn for this triangle, the big one. So we know that this is 5. This is a kind of special triangle that appears in the contests a lot. This is 5, so that's 5. The height is 2. Then the area of that triangle, shaded here, would be 5 times 2 divided by 2. We're not done yet. We still have x squared. The whole thing equals 6 as the area of the total triangle. Now we just solve for x. Very, very straightforward. I think I'll leave the rest to you to solve. This is more of just an exploration on how we can use these lines to facilitate the usage of this special 2 given here. Let's look at problem 18. So problem 18 says triangle ABC with AB equals 50 and AC equals 10 has area 120. So AB equals 50, AC equals 10. The area is 120. And let E be the midpoint of AC. So E here this and this should be the same. That's the midpoint. And as well, D is the midpoint of A and AB. So D is in the middle and the left and right should be the same. The angle bisector of angle BAC intersects DE and BC at F and G. So angular bisector, A is split into two equivalent angles. We'll call this one theta, the other one as well theta. And they're asking what is the area of quadrilateral FDBG, which the part that I shaded. So how do we approach this problem? As you can see, I already labeled AD and DB as respectively 25. The whole thing is 50. The D is the midpoint, therefore each of them should be 25, as well as on the right, AC is 10, AE is 5, and EC is 5. So you can notice that AF here should be equal to FG. That should be something very quickly that you should notice. I can do a proof here. So observe the triangle ADE, right? Triangle ADE has 1 degree, which is 2 theta on the top, and then 25, and then 5. Now look at triangle ABC. Triangle ABC is essentially just this, but enlarged to twice. So 5, right, each side, it times 2. 25, and also times 2. Because those two are similar triangles, and the second triangle, ABC, is twice the size of the first triangle, ADE. Therefore, all of these lines, if they are of the same angle, all of these lines should be of the proportion of 1 to 2 as well. So yeah, very simple way that you can figure out that AF actually equals FG. We are going to split up the quadrilaterals so that we can extract more information from it. We're going to draw a line between D and G. So upon drawing this line, we can notice that this triangle right here equals this triangle because they have the same amount of base. They have same value of base, as well as the same value of height. If you draw a height right here, they both share the same value of height. So these two triangles have the same area. Now we can set variables. We can call one of them A. The other one is also A. Now observe these two triangles. This is where the AF equals AG come in. We can split that into another two-part because this line essentially split that into half of A and then half of A. Same thing, AF and AG are the same. They have the same base. As well, they have the same height. Therefore, we can split that into two triangles, which are both of the same height. So I'm going to raise A here and then draw half of A. Now the tricky part is figuring out this part, because if we can figure out this part, that means we can add all of the A stuff together equals 120 and solve for A. And now we know that this quadrilateral is essentially just A plus half of A. That sounds convenient. How are we going to actually do this right now? So one way, how I did it, is that I drew another line, which is right here. I actually made another whole triangle. I'll call this point Q. So observe that AC and CQ. I'm going to say that the whole thing, the AQ, that would equal 25. I'll show you what I mean. So since this angle equals to this angle, they're both theta, right? Triangle ADG should be similar to triangle AGQ. those two should be similar triangles. Therefore, the area of AGQ should also be A, because, watch this, the area of ADG, as previously proved, that is A. Therefore, similar triangle, actually not even similar, they're congruent. Congruent triangles, they have the same amount of area. So, if we know that this whole thing, AGQ, is A, now we basically want to figure out what this is in order to figure out what this is. Or the other way around also works. Observe these two triangles. I know it's getting messier, so I'm going to erase some of them. Observe these two triangles, AGC and GCQ. Now, how do we figure out a proportion between those two triangles? Remember, they share the same height, right? They share the same height, meaning that their base directly dictates how much their area is. So, if they share the same height, this triangle should be calculated with 5 plus 5, well, 10 basically. 10 times its height divided by 2. And this one is, the whole thing is 25. 25 minus 10 equals 15. So 15 times its height divided by 2. So the proportion of triangle AGC to the triangle GCQ would actually be 10 to 15, or 2 to 3, the ratio. So in combination, 2 and 3 together, that's 5, right? 5 is basically A. So 5 of individual ratio should be A, and then 2 of those should constitute this. So 2 over 5 times A is the area of AGC, because the other one is 3 over 5A is GCQ. These two triangles together make up 1A, this whole thing. And now we split that into 2 over 5 and then 3 over 5. So right now we have the equality that we wanted. So we have A, the original one, plus half of A plus half of A plus this part we already know is 2 over 5A, and then that would equal 120, my bad. And then we solve for A. Eventually we can have that times 1.5, which we can figure out the quadrilateral area. So yeah, pretty simple. Not too much of a challenge if you are able to use this well, because this is fundamentally what allowed us to create the extra triangle, create the extra triangle right here and allowed us to solve the problem, because this means that these two triangles, ADG and AQG, those triangles are congruent. This is because they have one same angle, one same length, as well as another same length, which is AG. So yeah,